Okay, so a couple little interesting things I want to point out that I love when people tell me later that I did a mistake, so I have to correct my mistake. This is not fully simplified. Who does she think she is? Math teacher. Why is this one not fully simplified? What can come out? Yeah, 4 times 3. The 4 comes out, becomes negative 2 radical 3. So correct that, please, because that would be more simplified. Then a really interesting question came up when you guys were doing group work. That's why I love when you guys are doing group work, and then I can come around and answer your questions. So this interesting question came up. Let's go back for a moment in our packet to this problem that I solved. I didn't really solve it. I simplified it. And it was this one right here. This was on 7F. Okay. A student asked me 2/5 times 3/20. Okay. What if I didn't cross cancel? And in fact, I think it would actually be better if I didn't cross cancel. If I didn't cross cancel, I would multiply across. I would get 6 over the square root of 100, which is radical 6 over 10. Now, my answer is actually terrible. You don't know that yet, why it's terrible, but it's terrible because we do not ever want to have a radical in the denominator. It turns out that this answer is equivalent, and the reason why we know that, the answer I got and the answer she got are equivalent, and we found that out because we checked them on the calculator. We looked at the decimal equivalency. Okay, what I'm going to show you is how I can actually prove that my answer is the same as hers. So now when I multiply, if I multiply by 1, I will not change the value, correct? I'm going to multiply by the square root of 2 over the square root of 2. Why the square root of 2? Because the square root of 2 is in the denominator. What is the square root of 2 times itself? It's 2. Oh, because the square root of 2 squared is 2, right? Do you get that? So that'd be the square root of 4. So if I multiply the square root of 2 times the square root of 2, in the denominator, I'm going to get 5 times 2. What would I get in the numerator? Square root of 6, right? So this is the square root of 6 over 10. This is what we call rationalizing the denominator. Okay, so it's actually in your packet, but I thought it was an interesting point to go back to. She wanted to know, was the answer the same? So on page 6, it talks about rationalizing the denominator. Back in the day before, there was a time before the calculators existed. Can you imagine that? Well, when we divide by an irrational number, if I were going to do long division, this is how this would look. 2 divided by the square root of 3. Well, the square root of 3 is this crazy number that has a decimal place that goes on for infinity, right? It's an irrational number. So it would be the square root of 3 is that long number. Well, to divide by a decimal, you actually move the decimal to the end of the number. Do you see a problem? If I were gonna actually do long division and I were gonna move that decimal to the end of the number, is that even possible? Why not? Exactly, because it's irrational, which means the decimal goes on forever. So we don't ever want to have radicals in the denominator. Also, you can tell that it makes it really hard. If I have this answer and this answer is completely the same, well, I can't really tell on sight that they're exactly the same answer, can I? I want my answers to always look the same so that they're not confusing. So we're always going to want to take any number that has a radical in the denominator and we're going to want to rationalize it. Rationalize it means make it into a rational number. So we do this by multiplying by 1. Okay, anytime I multiply by 1, I don't change the value. The number divided by itself is 1. Yes. It was square root of 2 times the square root of 2, which gave you 2. This means that instead of having, in my answer, I had a radical in the denominator, and in her answer, she had this is called a rational number in the denominator. So just bear with me for one moment. We'll get through the example. We're not quite there yet. So anytime we have a radical in the denominator, we're going to, if we multiply it by itself, it becomes a perfect square. It becomes rational, right? If I do that to the denominator, I have to do the same thing to the numerator. 2 times the square root of 3 is 2 times the square root of 3, and then the denominator now becomes rational. So what you can see is that this number and this number are equal to each other. Okay, so let's just try an example here. I don't want to have a radical in the denominator. So in order to get rid of it, I'm going to multiply the denominator by that same number. Well, in order to multiply by a whole 1, I have to multiply it by the same thing in the numerator or denominator, right? Because anything divided by itself is 1. So I'm not changing the value here. So I get 5 radical 6 over radical 6 times 6 is 36. The whole point of doing that is so that what number will be in the denominator? 6. Oops, I write 3. 6. Okay, yes, 6. Ba-dum-bum. All right. Let's try one more together here. So always looking at the denominator, we're going to multiply by that number over itself, the square root of 5 over the square root of 5. And we get 20 times the square root of 5 over what? Yeah, and you could actually even skip to, you know that's going to be 25, and the square root of that, or the square root of 25, is going to be 5. Can you skip to that? That's fine with me. Now let's look at the whole numbers. Can the whole numbers reduce? Yes, 4 radical 5. Let's see, I think we might have time for one more. So let's just do this one. Square root of, what am I going to multiply the numerator and denominator by? Square root of 12. So we get the square root of 12 over 12, right? Because that would be 144, and then you'd have to take the square root. So it's always going to be that number. Now, can we simplify? This was the same question that came up before. Can we simplify the square root of 12? Yes, square root of 4 times 3 over 12, and you guys already have memorized, that's 2 radical 3 over 12. Can that simplify any further? Can my whole numbers, or they're not really, I guess it's a fraction. Can my, is going to be, yes, I'm going to write it over here. Radical 3 over 6, that's the same thing as 1/6. If you want to put the 1 out in front, that's fine too. Okay, I lied. I'm going to do one last problem. What am I going to multiply the numerator and denominator by? Okay, bear with me 1 second, okay? If I multiply by 8, I will get to 64. What number times 8 gives you an exact perfect square that's smaller than 64? Square root of 2 over 2. Watch this. You don't have to do it this way. You could do the 8. It's just you're going to have more steps to break it down. Why did I choose 2 here? It's because 12 radical 2. What is 2 times 8? 16. I didn't necessarily have to do 8 times 8 to get a perfect square. You see what I'm saying? As long as I can get a perfect square, then I can take the square root of that. What's the square root of 16? 4. So this becomes 12 radical 2 over 4. I'll change colors to make that a better correction. Over 4. Okay, what is 12 divided by 4, the whole numbers part? 3 radical 2. Do you see why? And actually, I could have done the same thing here. I could have multiplied by the square root of 3 to get to 36. All right, that's enough for today.